Reflect, production of gas. Mix sodium bicarbonate or baking soda with an acid such as vinegar. What do you see? The products of this reaction are water, carbon dioxide, and a substance called sodium acetate. During this reaction, you see bubbles in the solution as shown to the right. These bubbles are caused by the carbon dioxide gas escaping into the air as the reaction takes place. The chemical equation for this reaction is as follows. We have the reactants on the left, products on the right. We have production of light. The burning of logs in the fireplace is the reaction of compounds in the wood rapidly combining with oxygen. Combustion reacts such as the one required a heat initiative source to get started. Wood is made of cellulose, a combination of different substances that contain carbon, hydrogen, and oxygen. When this reaction occurs, a large amount of energy is produced in the form of heat and light. This reaction is similar to the reaction that produces the bright light, heat, and fireworks. Change in temperature. Chemical reactions can either give off heat or use heat. Perhaps you have had an injury and have applied a chemical heat pack to the area that creates a reaction that produces heat. When the heat pack is activated, the magnesium sulfate reacts with the water and produces heat, which you use to soothe your injury. Chemical cold packs work in the opposite way when a chemical like ammonia nitrate is mixed with water. That combination absorbs heat, creating an endothermic reaction, and feels cool to the touch. These temperature changes are evidence of a chemical reaction. Formation of a precipitate. A precipitate is a solid substance that forms and separates from a solution and often settles to the bottom of the liquid reaction. One compound reaction that forms a precipitate is the reaction in a solution of lead nitrate and potassium iodine. Each of these substances in a solution is clear and colorless, but if you mix a solution of each, lead iodine and potassium nitrate, they form products. Lead iodine is an insoluble, so it separates from the solution as a yellow precipitate shown in the image to the right. The potassium nitrate remains in the solution. The chemical equation for this reaction is as follows. So remember, we have the reactants on the left, products on the right. Now we have evidence of color change. The color of the substance may change when its chemical composition changes. An example of the color change as evidence of a chemical reaction is seen when copper wire is placed in a clear solution of silver nitrate. The product of this reaction is a blue solution. A color change represents more than just a physical change, such as diluting a substance or adding food color to a substance. The physical changes formed from food coloring are not evidence of chemical reactions. What do you think? Have you seen fireworks displays? These colorful little explosions are not just entertainment. When each firework is ignited, one or more chemical reactions takes place. The color of this display in the sky is determined by the elements or compounds involved in each chemical reaction. What can you observe during the fireworks display? Perhaps you hear loud sounds, see bright lights, and feel the warmth from the explosion, which are evidence of chemical reaction. Chemical reactions produce new substances. In a chemical reaction, molecules can change through the rearrangement of their atoms. More specifically, atoms of reactants can rearrange to form new molecules. A chemical equation can be written to show what happens to the atoms in a chemical reaction. A chemical equation is written like this. We have reactants on the left and products on the right. The arrow in the chemical reaction means produce or convert to. If you have seen water, you have seen the result of chemical reaction. In this reaction, oxygen gas, O2, and hydrogen gas, H2, rearrange to form water, H2O. The balanced chemical equation for this reaction is written like this. In chemical reactions, the reactants have properties different from the product's properties. For example, oxygen gas and hydrogen gas have different properties from water. In the gas form, water vapor may look similar to both hydrogen gas and oxygen gas. They are all colorless gases, yet they have different chemical properties. Oxygen is very reactive compared to both hydrogen gas and water vapor. Not all reactions combine elements to make compounds. Some reactions break down compounds into elements. When electricity is passed through water, the molecules react by breaking down into hydrogen and oxygen gas. The reaction equation is. Okay, so that part is going to help you fill out your slides for characteristics of chemical reactions evidence. So you can get started on that now.